In this video, we're going to look at the electrical energy questions from the Energy, Work, Power and Efficiency section of Mechanisms and Structures. So these are the 5 questions that we're given to solve in the course notes. And the main things we're going to be looking at for here is using our equations correctly and doing unit conversions where we have to. So we'll just tackle these one at a time, and maybe it will help us to start off by writing our formula for electrical energy at the top of the screen. Electrical energy is equal to current times time times voltage. And remember, our units are joules, amps, seconds, and volts, respectively. Question 1. A hot air dryer is activated for 30 seconds and the switch is pressed. The dryer operates a 230 volt supply and draws a current of 12 amps. Calculate the amount of electrical energy used. Question 1 is a nice one to start with because it gives us the 3 things that we need. And it gives us them with the units we require. So all I'm doing here is gathering information from the question. So I have time, voltage and current. I can write down my formula for electrical energy. And then it's just a matter of putting these 3 things into our formula. So 12 times 30 times 230. And then taking the time to make sure we calculate this correctly, which I will do just now. And so the answer we get here is 82,800 joules. And we could, of course, write that as 82.8 kilojoules if we wished. Question 2, slightly funnier wording here. A 12-volt car battery has a rating of 35 amp hours. That is, it can supply 35 amps for 1 hour or 5 amps for 7 hours. So that's the same amount of current supplied, just depending how long it's going to run for. So let's start with what's maybe a bit easier. We know the voltage is 12 volts. For our current and time, we can either take 35 amps in 1 hour or 5 amps in 7 hours. So let's just take the first one, current of 35 amps and time of 1 hour. Now this is where we need to stop and remember the time is in seconds. So we can't say it's 1 hour, we'll say it's 3,600 seconds, and that number comes from that's how many seconds there are in 1 hour. And now we have our 3 pieces of information, so we can use our formula. The current is 35, time is 3,600, and voltage is 12. Again, we'll calculate that, and we'll get a bigger number this time because we've run this for a much longer period of time. And that's what we get is 1,512,000 joules. That's 1.512 megajoules if we like to tidy our units up, but we're okay to leave our answers in joules here. Question 3. A portable electrical generator can deliver energy at a rate of 6 kilojoules per second. Calculate the current that can be drawn from the generator if the electricity is supplied at 110 volts. So let's unpack this one. So we're told energy is at 6 kilojoules per second. So that means we can take our energy is 6 kilojoules and our time is 1 second for using this formula. So we don't have to write anything with 6 kilojoules per second. It just means that we're going to have 6 kilojoules in a time of 1 second. And the voltage is going to be 110 volts. It tells us that. So this time we're asked to find current instead. We're not asked to find energy, we're asked to find current. Before we start to use our formula, we should see that 6 kilojoules is not our units we require. We need to change this into joules, 6,000 joules. And now we have everything we're looking for. Electrical energy is equal to current times time times voltage. So to rearrange this for current, we need to divide both sides by time and voltage. So the formula for current will be electrical energy divided by time and voltage. So let's put these values in. 6,000 is our energy, because we've converted that. Time is 1, voltage is 110. So put this into a calculator. we come out with a value of 54.5 amps. I rounded that to 1 decimal place. So let's look now at questions 4 and 5. Question 4. If the amount of electrical energy used by a 110 volt 30 amp DC motor is 1.98 megajoules, how long has the motor been in operation? So this time we're given voltage, current and energy and asked to find time, and we can do that. So our voltage is 110 volts, our current is 30 amps, and our energy is 1.98 megajoules. Then remember, to convert this into joules, mega means multiply by 1,000,000. So if you're not sure to do this, type it into your calculator. But what it means is that there'll be 6 digits after the 1 before we get to decimal place. So we'll have 198, that's our first 2 digits, and then 0, 0, 0, 0. And if you look, like, you put commas in, there's thousands and there's millions, there's our 1.98 megajoules. So that's how we know how many joules it is. But if you're ever unsure, just put 1.98 into your calculator, multiply by 1,000,000, that's 1 followed by 6 zeros, and that will convert from megajoules back into joules, which is what we need in our formula. So we have 3 pieces of information, and a formula has 4 things in it, so that means we've got enough to solve a problem. And just like in question 3, we'll rearrange this to find time. So time will be equal to electrical energy divided by current and divided by voltage. We divide both sides by I and divide both sides by V to get time by itself. This is 1,980,000. That's our 1,980,000 divided by 30 times 110 on the bottom there. And putting this into our calculator, we get the answer of 600 seconds. And it's fine to leave it like this, but you might be aware that that's with 60 seconds a minute, that's the same thing as 10 minutes. If you wanted to, you could write your answer as 10 minutes as well, and that would also be correct. And lastly, question 5. Question 5 tells us we have a turbine driving a generator, and its voltage is 110 volts. And output current is 3 amps. How much energy does it produce in 1 hour? So our time is 1 hour, and we've seen already that's 3,600 seconds. So that's going to be our time. And this is maybe a bit more straightforward after the last 2. It's returning to use our formula as we've been doing from the beginning and just substituting in values for I, T, and V. So we're going to have 3 times 3,600 times 110. That gives us our answer in joules. And the answer we get out here is 1,188,000 joules. And that's our answer to question 5. So that concludes the answer to all of the electricity questions in the notes. So we can see them all here. And so if you work through these, you'll be able to find the answers by watching this video back.